In this episode of the On.NET Show, Jeff Hollan is coming on. He's going to talk to us about how we could scale our workloads on Kubernetes using a really cool project called KEDA. Stay tuned and check it out. Hey everyone, welcome to another episode of the On.NET Show. My name is Cecil Phillip, and today we have my friend Jeff Hollan, which actually turns out when I was looking at the stats today, seems to be like our most repeated guest on the show. He's back today and he's going to talk to us about some really cool stuff about KEDA and Kubernetes and all types of great stuff. So Jeff, thank you for coming on, man. How have you been?
I've been fantastic. Thanks for having me. Let's keep this trend going. I love coming on. I always try to find new exciting things to talk about, and then I'll just send you notes. I'm like, does this meet the bar? Can you get me back on again?
Right. We got to keep a competition going and make sure that I keep track of like how many times you've been on and stuff.
Yeah. No, it's great to be here though. Doing well. Excited to talk about all things event-driven and some things Kubernetes and serverless.
Sure. So I've been, I pay attention to what's going on online and in the community and stuff. And I've been seeing you talk a lot about this project called KEDA. And so, I've seen you give some presentations about it. I've seen blog posts about it. But I thought I have to have you come on the show and let me know what exactly is this thing about. So could you give me a really quick elevator pitch? Like, what is KEDA and like, what is it supposed to do?
Sure. And maybe like kind of how I like to frame this is for those who don't know, my regular job is the program manager for Azure Functions. So serverless compute where you like, hey, run my code, go run it at crazy scale. And where we spend a bunch of our time is the scale part. It's like, how do we make it so that if you want a function that's processing on queue messages, that if there's a million things in that queue that we can really quickly and process all those events. And what we noticed as a team is we were learning and working with users who wanted to use specifically functions in Kubernetes, was that Kubernetes did not have a very good way to do event-driven scale. Kubernetes has auto-scaling there. So if you publish a .NET app or any other app to Kubernetes, it can scale, but it wasn't optimized in the same way that Azure Functions is optimized. Like I almost think of it like, imagine, Cecil, that we're throwing a huge party. We're in a world that we can throw a huge party. And you're like, you're like, hey, Jeff, you're in charge of food. One way that I could go about this, which would be super inefficient, is I could say like, okay, I'm going to start and I'm going to order one pizza. I have no idea how many people are going to come to this party. I'm just going to order one pizza and I'm going to watch. And once there's only like 2 slices left, then I'm going to call and ask them to deliver another pizza. It would work. Everyone would get enough food. But if you had 1,000 people show up to this party, it's not going to be, most people are going to be really unhappy or waiting for a long time for their slice. So the better way would be that I'm like, hey, Cecil, how many people are coming to your party? And you're like, oh, it's 1,000. I'm going to order whatever 200 pizzas from the get-go and have them all there ready to go. So KEDA does the exact same thing, but instead of pizzas, it's, I need CPU, I need this code to run, and KEDA lets it know, hey, there's a bunch of messages in this queue. There's a bunch of work that needs to be done so we can do this really good event-driven scale stuff. So it brings that capability into a Kubernetes and microservice world.
All right, so Jeff, every time I heard about KEDA, it was always tied for me with like Azure Functions, like KEDA, Azure Functions, KEDA, Azure Functions, right? So I always thought that KEDA was a project that allowed us to run functions on Kubernetes. But I kind of feel like that's not the case. So I'm not totally sure. So could you debunk that for me for a little bit? Like what exactly does KEDA do in relation to Azure Functions? Or are they like 2 completely different things? Like what's the relationship there?
Sure. Yeah. And that's the primary motivation, like why our team in Azure Functions started this project and continue to fund and maintain it, because we do want to enable people to run Azure Functions in a container inside of Kubernetes on whatever cloud or platform they want, and have those functions behave the same way, do that cool scale in, scale out thing. However, when we designed it, we really wanted to build, I kind of mentioned the problem Kubernetes in general has, where it doesn't do that event-driven scale thing of seeing how many people are coming to the party. And so we're like, well, let's not just build this in a way that it only benefits Azure Functions. Let's make sure we build it in a way that any type of application that you can build could hook into the same scale. And so, yeah, its primary use case for my team is, hey, take your functions and run them elsewhere. But we have a bunch of people, in fact, probably more so now. Like KEDA is a CNCF project. It's out in the open. We've got contributions and users from a bunch of different places. So some people are using it with functions, but a lot of them are, hey, I have this .NET worker service that's not using Azure Functions at all, but it's pulling messages from a queue, or it's pulling messages from an event hub, or wherever it's pulling messages from. Can this service do a function scale thing? And so we've built it as the answer is yes. So KEDA is just this little service that makes any workload do the Azure function scale thing, but it doesn't have to be an Azure function that it's actually scaling.
Got it. So then I could have anything, my Python thing, my .NET thing, my Go thing, console application X, and then like, hey, I want you to scale this pod for me, or this deployment for me, and then it'll just kind of figure it out.
That's exactly right.
That you set up.
Yep, that's it.
All right, cool. I know you also mentioned that this is also part of the CNCF, right, which stands for like the Cloud Native Computing Foundation. What was it like for you to start working in that world and, get this project to the point that it could be, one of the hosted projects there?
Yeah, it was always a goal when we were first meeting about, how do we do this in Kubernetes? We're like, oh, this would be awesome to have in the CNCF, because if you're unfamiliar, that's the foundation that owns Kubernetes, the Kubernetes trademark, all the Kubernetes work. A bunch of Kubernetes related projects are there, like Helm, Prometheus. If you're in that world, it's something you know. And it did take a bit to get there. Like they have kind of different levels of projects. KEDA right now is what's called the sandbox project. So there's a lot of requirements that it has, but we did have to showcase, hey, this is something that's useful to the ecosystem. This is something that's getting adopted from more than just Microsoft. Like, we need to make sure that this is valid for not just a single vendor. And the bit to do it is it's us saying, we, the Azure Functions team, the Microsoft team, Red Hat, who partnered with us on this, we don't own this anymore. We're going to give this to the community. We want the community to build it with us. We're not in charge of the trademark. We can't, there's a world that KEDA V3 or V2, they make it so it's incompatible with Azure Functions. I don't think it's going to happen, but it could happen. And we're like, look, if that's where this project's going to go, we're going to give it to the community. So there was a bit of work there to show that we were, we meant what we said, but it's now officially there and open source and being used by a bunch of different folks.
That's awesome. And you know what I love about, seeing projects come out of Microsoft and go into some of these open source foundations is that now it's, again, like you said, it's not just a Microsoft thing, it's an ecosystem thing. So, you get to partner and build relationships with these different companies and also see different scenarios of it, how people are actually using some of these projects that we're building. So I'm sure from that perspective, there's been a lot of learning and a lot of insightful, feedback that's come from being in that foundation.
Yeah, and it's like every week we've got these weekly stand-ups. And, there's 1 or 2 people from Microsoft, but then there's 7 or 8 people from everywhere else. And we're all meeting together to understand, what could this use? How could it benefit? So it's been a really eye-opening project, but it's a lot of fun. And I've really liked that flavor of let's build this and owned by the community and not just, hey, this is what Jeff Hollan wants, or this is what the Azure Functions team wants. And so you can use it if it's useful. This is something very different.
Got it. So Jeff, I know you didn't come on this show without any demos. I know they're demos. So why don't we take a moment and switch over to your desktop really quickly and see what does it feel like to actually build something that runs and scales inside of KEDA?
Sure. So let me share my screen. Great. So what I'm showing here, this is not actually an Azure function. This is a .NET worker template. If you're familiar with the .NET worker service, I've written a background service here that's going to pull in messages from a queue. In this case, it's an Azure Service Bus queue. And so I've written this up in my project here. I've got a nice Docker file for it. And here I've defined a few things that Kubernetes needs to actually run this app. And so I have, if you've used Kubernetes before, this is a YAML file that says, hey, this is the container that I want you to run. This is the connection string that you should use for the queue, just stuff to get that container up and running. But the secret sauce is this auto-scaling stuff. This is what KEDA does. I'm saying, hey, this is a KEDA YAML definition, and I'm going to say, hey, that order processor .NET worker service that I deployed, I want you to scale it based on queue messages coming from Azure Service Bus. So here I've told KEDA, hey, scale this thing based on queue messages coming from Azure Service Bus. This is how you can authenticate with that service bus, whether you're using connection strings or pod identity. And I can even define how aggressive should scale. So here, by setting this number to 5 for queue length, I'm saying every 5 messages on that queue, I kind of want 1 instance of that container running. So if I drop in 20 queue messages, I'm kind of telling Kubernetes 4 containers running my .NET Worker is probably the right number here. And then I deploy this to Kubernetes and it does the rest. And so here I have here in this console window, my Kubernetes cluster. And here is my order processor container that I was just showing you. And what's cool here is this is something Kubernetes can't do by default, but you'll actually see right now it's running at 0. It has no containers running. It's all the way down to 0. It's not taking any compute. And the reason it can do that is because KEDA is looking at that service bus queue and it said, hey, there's no work here. There's no queue messages. So why should we spin up this .NET Worker? So it scaled it all the way down to 0. So I'm saving my compute processing for other workloads like this website that I have running that actually is running. And so kind of the magic happens here. Let's go ahead and watch the containers that are running in my cluster. Here's a website that I have that just visualizes the queue length. I'll show you that in a second. Actually, I'll show you that right now. So I have this website that shows us the queue length. You can see it's at 0 right now. So let's go ahead and drop a bunch of messages here. Let's have a bunch of people show up to this party. Oh, what's a good number? Let's do 1,000, I guess.
That's
so
a
we're
lot
gonna,
of pizzas, man.
Yeah, a lot of pizzas. We're gonna drop. I even see pizza show up here on the left. So I'm dropping 1,000 messages here in this queue. You can see here in this visualizer, this queue is getting filled up with a bunch of stuff. And if we switch over here to this window, you can see really before I even finish that first sentence, KEDA's been like, hey, Kubernetes, you know this order processor container you gave me? I can see there's a bunch of work piling up for it. And so very quickly it shot up to 4. Now it's scaling out more to 8. And KEDA's driving this thing out. It's scaling out really, really quickly, much faster than Kubernetes by default would do. And that's because KEDA's looking at this bar chart that's literally got off the screen. I didn't realize this page only goes to 500. I've blown off my own chart, but that's okay because KEDA's making sure that my container is consuming that and draining that. And if we stuck around here for a few more seconds, you'd see this bar chart go all the way down to 0 and probably even scale out a few more times. So that's kind of what KEDA's doing for me. I had my simple service bus process, could have been a service bus Azure function. In my case, it was just this worker project. I told KEDA that, hey, this thing cares about queue messages. And now KEDA's making sure that I'm scaling as I need to in my Kubernetes cluster.
So Jeff, I was taking a look at that YAML file that you were just showing, and I noticed you had like certain triggers that were there. So one of my first questions is like, what are the different triggers that are supported in the scale up process with KEDA?
Yeah, there's a ton. I'm going to switch over here to the KEDA landing page, keda.sh, which is a great place to get started. And if I just hover over here, I know it's a little bit small. I think I have a grid view lower. I'll zoom in here, but you can just see there's a bunch of different event sources that KEDA knows how to talk to and scale your workloads on. So again, this is a CNCF project. It's not just Microsoft. So you'll see here, there might be AWS CloudWatch events or Azure Event Hub events or MySQL events or RabbitMQ events. So there's about 20 right now. These are constantly being contributed and added. But these are just an example of some of those event sources that if you have work or data that's happening in one of these spots, KEDA can now scale your container based on these events.
Awesome. And I'm guessing for folks that are familiar with Kubernetes, I'm guessing there might be like Helm charts and deployment scripts and things of that nature that can help us like get this thing set up and installed in our cluster.
Exactly that. And one of the other kind of founding principles we had when building KEDA was we didn't want to replace the Kubernetes ecosystem. We just wanted to extend it and enhance it. So all of your regular CI/CD process tools, whether it's Helm or you're using the autoscaler policies as it is, we just attach alongside it. So we're not replacing anything Kubernetes provides, tools or otherwise. We just kind of amp it up with this piece of functionality. So if you go and read through some of these docs, you can even see how we're just using the extensibility points already in these tools in Kubernetes to add this functionality.
Got it. Now, assuming that we're running in Azure, and like you said, like KEDA can run anywhere, as long as it's inside of Kubernetes. But let's assume that we're running in Azure. Does this work with ACI and the virtual kubelet features that we have there?
It does. That actually gets pretty exciting. In fact, I'll go ahead and just stop sharing my screen here for a second. So this is one of the fun parts about that serverless promise, is that in Azure, we have this feature called virtual nodes, where imagine that I did that queue demo I just ran, but I need to go really, really far, really, really fast.
Sure.
If I run out of actual compute, like what if I only have 10 servers in my cluster? What if I need 20 to handle the amount of pizzas that people are ordering? You can actually scale out to these serverless containers, these virtual nodes. KEDA parties in that world as well. So KEDA can tell Kubernetes, which can tell Azure, Jeff's saying he needs some more containers here running this dotnet worker. I don't have enough resources here on my VMs. Go ahead and spin up Azure container instances. Go ahead and spin up these virtual nodes to scale out indefinitely into these serverless containers. So that works great too. You just have to modify your YAML with the little annotations for virtual nodes and say like, hey, run exclusively on these serverless containers or burst out to these containers. But it all works well together.
And also from an application perspective, there shouldn't be any changes to the way that my code runs. There's no SDKs or packages for me to install. Obviously, like we're not trying not to write to the file system or anything like that, because these things spin up and down. But other than that, like my code is essentially the same, right?
Yeah,
like
exactly.
I listen to queues, I get messages, I make HTTP requests, I do database things, and my app doesn't need to know about KEDA. It doesn't even need to know that I'm running in running in that world at all. Like I could just write my app, and then now from an infrastructure perspective, then Kubernetes will just figure it out and auto scale that thing for me.
Exactly right. And you can even have maybe 3 apps that don't use KEDA and 1 app that does, all running in the same cluster. It's just up to you. And the app thing about KEDA, they're just running along, and then one day you're like, hey, KEDA, keep an eye on this queue and scale this thing, and it will do it. But you don't have to change any code. You could bring existing apps, pop in KEDA, pop off KEDA, everything works fine. You're just kind of messing with these YAML files.
Got it. Now, how does KEDA play along with some of the other features that are inside of the Kubernetes ecosystem? So I know there's things like Istio, and I heard people talk about things like Knative, right? Is there any overlap with KEDA and these types of projects, or can they kind of just work side by side just fine?
Sure. Yeah, they can work side by side. In fact, the Knative project has a sample in their repo, which is, hey, what if I have things I'm publishing to Knative that are more queue triggered or queue based scaling? I would say one big distinction, if you're learning about this Kubernetes ecosystem, maybe you've heard words like Knative.
Yeah.
Knative's approach is it's trying to be an entire platform. It's like 50 features that does everything from Istio-like things to scaling things to deploying things. It's kind of doing that all in one. And it very much is a very opinionated way. So when you install Kubernetes on a cluster, you now need to run and manage things in a Knative way. It's this really encompassing platform. You can pop in KEDA alongside that too, and it's cool. However, the approach is a little bit different in that when you use KEDA, it's just a single feature. We're just like, hey, this is just the scale piece. And yeah, Knative does scaling things too, but you can kind of have the KEDA thing run alongside it as well. But it's very low opinionated, non-intrusive approach. So they work well with each other. It's just worth noting, if you're kind of like saying, do I want Knative or do I want KEDA, realize that the scope of what each of those projects are doing are pretty different as well.
Got it. So Jeff, if I was supposed to like I say, I want to try out KEDA, I want to try it out in my own clusters and things of that nature, where would I go exactly to get like the getting started information? Maybe there's some sample apps or some demos that I could take a look at to see, what the getting started experience is going to look like. Yeah,
the site I showed you a few minutes ago, the KEDA.sh, so KEDA.sh. That's the main landing page. It'll take you off to a video where I've got like a whole 45-minute presentation around this thing from KubeCon. And then there's a bunch of samples. We've got samples of using it with functions. The sample I showed you of a queue-triggered dotnet worker, that's one of the open source samples that we'll link to from that page. There's like 50 different samples at this point that you could go play around with. So definitely worth going and poking around. It's one of those things that You follow one of those quick starts. It takes about 30 minutes. Maybe it's the first thing you've really done with Kubernetes. It'll kind of walk you through a lot of it step by step. So definitely encourage you to check it out. Try out something new. Spin up a cluster in Azure. Try it out. Go tear it down. Hopefully, it only costs you $1 or $2 to run it for that a low amount of time. But it should have everything you need there from that KEDA.sh.
Cool. And so what we'll do is we'll make sure that all that information we'll put in the show notes. So if anyone's watching, hopefully you're watching, if folks are still watching, then you can go down and check out the links and the samples and all those types of things. And then while you're there too, we'll make sure to put in some of Jeff's older episodes so that we make sure that we keep getting hits on those so that we'll encourage him to come back on another time.
Yeah, and can we just book like 3 weeks out from now as well? And I'm sure I'll find something more exciting to talk about.
Exactly. I'm just going to put stuff on your calendar and be like, what are we talking about today, Cecil? I don't know. Whatever you want to talk about, man. Just go for it.
No, this was a blast. So thanks so much. And yeah, if you have questions as well, feel free to reach out to myself on Twitter as well. I'm more than happy to answer any questions folks might have around any of this.
Awesome, man. Thank you, Jeff. Appreciate you coming on. And thank you all for watching. This has been another episode of the On.NET Show, where we learned all about scaling inside of KEDA.